Hi guys, and welcome in the next video. So let's continue with our KUKA robot and let's move on to the next topic. So in the previous video we spoke a little bit about how to teach the TCP and what the TCP is. Now when we have the TCP we should move forward and talk a little bit about base. So I'm going to explain you what the base frame is, how to use it, how to define it, and why do we have it. Ready? Let's get started.
5, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Alright, so let's talk a little bit about the base frame. So remember, I spoke with you about the word coordinate system. So the word coordinate system by default is located in where the robot root is, and that's the base of the robot. Also the base by default, the base 0 is located in the same spot. So you can remember as the robot root word coordinate system and the base 0 is located in the same spot. Now in order to move that base you need to teach it, and we're going to do that on the exercises. And you're shifting the base frame from the robot base onto another place. Why do you want to do it? There are quite a few ways. At least two that I'm going to mention is number one, it's going to be easier for you to jog around the base frame that you will teach, because maybe it's not going to be a perfectly level surface, maybe it's on an angle, so it's going to be a little bit easier for you to jog like this around that angle. Or maybe you're using a robot, for example, for spot welding, and you need to know all of the robot coordinates, so you need to know where each spot is located in reference to some point, and that point is going to be the origin of your base. So basically you will know how far the point is, so that's going to be your origin of the base coordinate 0, 0, 0, and you're going to know exactly what's the distance from here onto this point. Otherwise it'll be from this point to the robot base. So I'm going to explain that in a little bit. So let me show you why would I teach a base. So for example, if we have let's say something located in here, right? So let's say we have a workpiece that we're going to work on that is going to be located in here. So there are quite a few ways. You don't necessarily need to teach a base for that, but it will be much easier for you to do all of the operations if that base is going to be taught. Because of course, if you have a gripper, for example, right, you can navigate with the gripper to get here. But it probably is going to be a little bit easier if you're able to navigate exactly like the base is located, right? So that's why you would teach the base. That's going to be your point number one. The second dimension is going to be to know where the coordinates are. So let's assume I'm a robot, right? And you want to know where the edge of that, let's call it hill, is this one. So it's going to be kind of hard for you to calculate, because I'm a different height, that's at a different height, at a different angle that I am. So yeah, you will get the reading from here to me, to the base. But what you're interested in, where is it located in here? Because you don't really care. I can be here, this can be here, 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 wherever, right? So that's why you will teach the base, and you're going to define the 0 of the base, the origin, in one spot. So let's say here, right? So you're going to teach that spot here, and that's going to have your coordinates of 0, 0, 0. Now, because for you this is going to be a flat surface on an angle, if you move here, that is going to be the distance from here to here that's going to be calculated, instead of being calculated from here to here on a random angle. Well, not a random, you will know it, but on an angle that you don't really want to have. And it might be a little bit of misleading information. So if you teach the base in here, and that's your 0, 0, and you're going to go here, probably that's going to be, let's say, around 18 centimeters, so 180 millimeters. And you will know that the coordinates of this is going to be, let's say this is going to be your x direction. So it's going to be 0, 180 in x, and 0 in y, because we didn't move in here. Now, if you would take a look at this point from my perspective, That's going to be probably like 45 centimeters, so that's going to be like 450 millimeters in Y, and then let's say 200 millimeters in X, and probably like, and probably like 300 millimeters in Z. That is not very clear information. That's why you would like to know where that point is located over here. So that's the whole idea of the base. And of course, as I said, if that's going to be your TCP, that's going to be the robot in here, you can navigate nicely around the base. You're going to move nicely around the edges, around the corners, whatever you want to do, it will be much easier for you. And then the base comes very handy with the vision programs and everything else that we're going to talk about later. Okay, the right hand rule, I hope you remember it, guys. So the right hand rule will still apply like always. So as I said, I'm the robot base. That's your right hand rule for the robot, for the world coordinate system, and for the base 0, as I said. Now what you're going to do, wherever you will pick your 0, let's say in here, you're going to move your right hand rule, the origin, to this point. And you can define it which way you want to go. Also very handy, because let's say for one of you, you want this to be your X direction. For other guys, you want this to be your Y direction, and somebody else might say, no, I want this to be my Z direction. You can do all of that when you will be teaching your base frame. The way how we teach the base frame is pretty simple. It's kind of like we teach the TCP. Very important, you need to have the TCP taught before you can teach the base. Super important. So basically what you're going to do is you're just going to define where your 0 is of the base frame. So basically where the origin of your base frame is. So let's assume it's going to be here. And then you need to show two directions, X and Y. So you're going to move your robot to here, touch up that point, that's going to be your X. Then you're going to move it here and say that's my Y. And that's it, your base will be taught. Robot will make the calculations and he will know that this plane is now your base. You can teach a lot of bases, by default 32 in KUKA robots, so plenty of them to teach, plenty of them to use. And I guess that will be all, guys, from the introduction. Let's head out to the exercises.
Hi guys, and welcome to the exercises. So let's teach the base frame. So as a base frame, in here I'm going to choose that table that you see, and we're going to try to move along this line and that line. Why? Because I don't know if you can see, but the robot is located on an angle. That means it's not straight to the table. And if I try to move in a world coordinate system, it doesn't follow the lines, but it follows the base 0 or the world coordinate system. So that's why we're going to teach it. So first of all, maybe I'll show you how you're going to know what to choose for your base. So as you can see in here, you want to see at something that's on the same level. So that part of the table is at the same level. It doesn't change the height. Like you cannot just use this part, that curvy part for the frame, because you just cannot teach it on a curve. It has to be a straight line. So there are 4 points in here. First in here, second in here, 4 in here, 5th in here, and they can represent our frame. So I'm going to use those points to define our origin and as well as our frame, as our base. So what I'm going to do actually is I'm going to choose this point as the origin, or I'm going to choose this point as an origin. This is going to be our X direction, and this is going to be our Y direction. So what we need to do is we need 3 points. The origin point, which is here, our X and our Y direction. And as we do that, we're going to move perfectly straight in here, as well as in here, which is going to be the same line in here, like in here. So you will see everything after teaching the frame is done. Okay, so let's open Teach Pendant. And I'll show you where you can find the frame. So first of all, you cannot have the program selected if you want to teach a new base, because the robot won't let you. Let me show you. So you want to hit on the KUKA icon. You want to go to startup, and you cannot do calibrate when the program is selected. But the moment we cancel the program, everything opens up and we can calibrate. And we want to calibrate the base. And there are the methods I told you about. There is 3-point methods, indirect methods, numeric input, and you can also change the name of an existing base. So today we're going to focus on the 3-point method. The numeric input is the same as we did for the TCP, where you just need data from someone, from a measuring tool or team, or from the CAD, and you can input the values directly into the robot. Indirect method is being used if you have a base and you want to shift it. So for example, let's say, let's imagine that this table is out of the reach of the robot. So it will be like in here. So, but it's that long that the robot can reach a part of it. So you can measure the base here, but if the table is that long and you want this point to be your origin, that's where the indirect method comes helpful, because you will teach the points in here, but you will say that the origin, the 0, is located somewhere here. And you will do this by just inputting a fixed value into the indirect method, and that's going to offset your base. I will just show it very quickly later. Okay, so let's start. So let's do the 3-point method. So we're going to select 3 points. We want to teach the base system number 1. Let's give it a name. Let's call it table. Okay, we'll hit enter. And let's go to the next step. So in the next step, what's very important, you have the tool name, and the tool name is the tool that you have selected in here, because guys, you need to have the TCP in order to measure the base, because the tool is going to point to the points of the base. So it's also showing you which tool you have selected. And as I mentioned, I don't know guys if you remember, but we taught the gripper TCP earlier, and the TCP is located right here on the gripper. So we're going to use that point to teach our frame. If you are unsure where your TCP is located, simply go out of your calibration tool. Yes, we want. And make sure that your gripper is selected. Select your tool and check it by jogging around that tool. So we want to jog around B, let's say, and you can see that that point is our base. Our tool. So we're going to use it to teach the base. Okay, now that we established that, let's change the coordinate system to Word, because that's going to be the easiest one to use to navigate. And let's go back to our 3-point method. Okay, let's name it again, table. Let's hit next. Reference tool number 1. Okay, and 3-point method, we can hit calibrate. That means we need to move to the first point as the instruction says, and we need to tell where the origin is. So as I said, I choose that point right here. So let's move to that point with the TCP. So I'm going just to move down, move the teach pen a little bit. Actually, let me move like this. Okay, I'll keep going down. Okay, let's zoom in a little bit. Okay, we're almost there. So we're going to jog a little bit more. Let's slow down. Okay, let's move a little bit more. Too much. Good that we're on a simulation. We didn't crash into anything. Okay. As you can see, I'm touching the pin right now, or dot. So I'm pretty happy with that point. Our TCP that's located right there on the edge is right on the line. It's in the center of the dot. So we can save, actually it's not in the center of the dot, and we're not going to use the center. Let's move on the edge here because it's going to be easier later on. So I'm going to jog a little bit. And why am I choosing this point? Because later on when I move to the other side, it's going to be easier for me to see it and to reference. Because if I choose the middle of that dot, when we will move the second dot that's located over there, it will be very hard for us to find it. But if we choose the edge, and the edge that's going to lie on the line, well, it will be pretty good. Okay, let me get there. I might speed up the video for you so it doesn't take that much time. Okay, I'm pretty happy with the point that I have, so I'm going to hit calibrate. And we're getting a pop-up. Should the position be assumed, measurement will be proceed. Yes, we do. Okay, now we'll say the message is saying move the TCP to a point on a positive x-axis of the new base coordinate system. And as we said, we want to choose our x here. So I'm going to move the robot from this spot right here. So what I'm looking at and why I chose the edge, because right now what I'm going to do is I'm just simply going to move along the line all the way here to the same edge right here. So I'm going to get rid of the error because it's going to be hard to assume where the center of that dot is, but it's going to be easy to find the edge and the line. Okay, so let me move it and I'll speed it up for you so you don't need to watch everything very slow. Okay, I'm pretty happy with what I see. We have the second point, so I'm going to save it as the X direction. So we're going to hit calibrate. On the pop-up, we want to say yes. All right, and now we need to move the robot TCP to our Y. So as I said, our Y is going to be that dot in here. So let's move it over there because that dot is perfectly aligned in here. Okie dokie, and I'm pretty happy with the point that we have right here. So let's save it as our Y coordinate. So we're gonna hit calibrate, and in the pop-up window we wanna say yes. And as you can see, the base 3-point method has been completed. So we taught our base system number 1. We have how it's located relative to the robot. We have X, Y, and Z coordinates. And as I said, those coordinates are the coordinates from the origin that we taught from here to the robot root. Okay, let's save it. We have successfully saved it. Let's close it. And well, what now? Let's test it. So we want to select our base number 1, which is table. Now we want to change our coordinate system from the word to the base, or actually better, let's do this first. And as I thought, our X should be along this line, so it's the same as this line. So as I jog in X right now, this is going to be our X positive because that was 0. So we always show the positive direction. This is our Y positive. So as I hit X positive, the robot should move to the left on the line. Let's try it. As you can see, the robot is following the line. Let me slow it down a little bit, zoom it in. So the robot just goes on the line that we thought, follow the TCP from here to that dot. As I move, zoom it out a little bit. As I move along the line, the robot is following the path just perfectly. So let's go back to our dot. Okay, we are back at our dot. Let's move a little bit more to the center of the dot, or to the edge actually. Okay. Right now, as we are at the edge of the dot, as we move to the other side of the dot using Y minus, you'll see that's going to be pretty easy to do. So let's hit Y minus, and the robot follows to the dot. That's our origin. So let's take a look. Awesome. So we are at our dot. We can move a little bit more in Y negative to get to the beginning of the dot. So as you can see right now, I'll show you the difference. If we're going to move the robot right now using X positive, we're going to follow the line that we thought. But if we change the coordinate system to word and we're going to do X positive, the robot is going to move into pretty much the direction defined by its mounting. So that's why we teach the base. Another thing why we teach it, that's, as I said before, it has something to do with the position. So as we display the actual position in the Cartesian coordinate system, and we choose the base, as you can see, we are 25 millimeters in X and 37 millimeters in Y from our origin point, which is located in here. That means if we change the base and we're going to go minus in X, just looking at the values here, don't look at the robot, and minus in Y, look at the values, don't look at the robot, we are at close to 0, 0. This is our dot. That's our origin. Now, as we change the coordinate system to a root, which is going to be, for example, number 2, that's not taught, you can see that those are the values from the TCP up to here. So that's how you teach the 3-point method. If you want to do the other methods, go ahead and try it. I'm just going to briefly describe it. So as we go to the numeric input, you can use, let's say, number 2, give it a name if you want, and you need to put all of the values by hand that you were given by the CAD or by the measurement team, and that's how you're going to use the numeric input. And the last one, the indirect method, is if we have a base dot, we can offset the known base by a fixed amount. So if we knew that that's our base, we can shift the 0 to here. All right, and that will be all, guys. Thank you for watching.
All right, I hope you enjoyed the video. Like always, don't forget to leave your comments down below. Give it a like, subscribe, and see you in the next video. Bye bye.